Okay, we continue with the quantization. Uh, the palm sample still represent the voice signal in analog form. For digital transmission, future processing is required. Code modulation is a technique used to convert the palm sample to binary with code for digital transmission. PCM encoding is a two-step process performed by codec. The first step is quantization, where each sample is assigned a specific quantizing interval. The second step is PCM coding of the quantizing interval into an 8-bit PCM code word. It is discussed with the text that flow. Converting palm sampling to digital signal involves assigning the amplitude of palm sample one of whole range of possible amplitude values, which are divided into quantizing intervals. There are 256 possible quantizing. Okay, let's explain the process sampling convert a time varying a signal into the discrete time signal. A sequence of real number. However, we need to find a finite set of values we can convert to binary number quantizing process exactly serve this purpose. So, bit depth. Bit depth means the number of bits in each sample. The most common bit depth in analog digital conversion is 8-bit, 16-bit, and 24-bit. The number of discrete quantization level is determined by the bit depth. The bit depth defines the resolution of quantization process. For the bit quantizer, there are 2 the power bit quantization level. So we can convert 8-bit dip equal to 2 power 8. So the level is 256. And okay, let's move on this one. Let's use 8-bit dip to measure our sample. It means the 256 level, and each horizontal line represents each level. Each level is associated with a specific bit value. Quantizing process is the process of rounding of amplitude of flat top sample to a manageable number of levels. We try to make each sample to match each level because each level has a specific bit value. Now we are ready to encode this sample with 8-bit dip. Okay, we can see it would match decimal number to 55, which is equal to binary number 1111111. The sample at very bottom would be aligned with decimal value 0 in binary. Thus, any sample match different specific level with a specific binary value. Okay, next is type of quantization. So quantization it has 2 type of uniform. One is ununiform quantization, and another one is non-uniform quantization. So uniform and non-uniform quantization from the above, it can be seen that the quantization noise depends on the step size. When the step have uniform size, the quantization called as uniform quantization. For uniform quantization, the quantization noise is the same for all signal magnitude. Therefore, with a uniform quantization, the signal to noise ratio is worse for low level signal than for high level signal. Non-uniform. Non-uniform quantization can provide fine quantization of the weak signal and coarse quantization of strong signal. Thus, in the case of non-uniform quantization, quantization noise can be made proportional to signal size. The effect is to improve the overall SNR by reducing the noise for predominant weak signal. At the expense of increase in noise for the rarely occur strong signal. Figure above compare the quantization of strong signal, whereas a weak signal for uniform and non-uniform quantization. So in summary, uniform quantization, the quantization level are uniform space. Each interval has the same width, simple and easy to implement. Commonly used in the most digital audio and video application. And non-uniform quantization, the quantization level are not uniformly spaced. More levels are allocated to smaller amplitude value and fewer levels to large magnitude value. Okay, in this slide we're talking about quantization error. So quantization introduces an error because the continuous range of value is approximated by a finite set of levels. This error is known as quantization noise or quantization error. Quantization error, the difference between input value and quantization value. Signal to quantization noise ratio (QNO), a measure of quality of quantization, defined as the ratio of the power of the signal to the power of quantization noise.